green.
Okay. So now we are going to look at EER. EER is a continuation of entity relationship modeling. It's a continuation. Guys, mute your mics, otherwise I'm going to start dropping you off. So it is a continuation of entity relationship modeling. However, whenever we are talking about enhanced entity relationship modeling, you have to think about one aspect or two or three things. But the two are usually derived from the one aspect, which is the specialization and generalization. So enhanced relationship modeling, just know that you're talking of aspects of specialization and generalization. And when you're talking of generalization and specialization, we are looking at attribute and relationship inheritance. Some of you, I believe you have done object-oriented programming. In object-oriented programming, you have looked at terms like encapsulation, polymorphism, inheritance, etc. So here we basically look at, we have inheritance. So in EER, this first, the first bullet is not part of enhanced entity relationship modeling. But I just included there because in the previous—
Madam, we're not seeing your screen.
You're not? Really? Okay, let me reshare it again. Can you see it now?
Yes, we can.
All right, thank you. So I was saying that in entity relationship, enhanced entity EER, basically we're looking at issues of specialization and generalization. And from a scenario given, you can be in position to ascertain whether this particular scenario can have a specialization or generalization. When they give you a scenario, they will not tell you that please you draw a conceptual design which is an ER model, or you draw a conceptual design which is an EER model. No, you have got to read the scenario and then be in position to identify whether there is anything to do with specialization and generalization. So we are going to look at certain aspects within the ER model that are not acceptable. And it is imperative that these aspects are dealt with before you proceed into your logical design. Of course, they can be dealt with at the logical design level, or you can decide to deal with them at the conceptual design level. So depending on what deems fit, you can do any that you want, or you can deal with these aspects at any given stage. So what are these aspects that are not acceptable in ER modeling? The first one is a many-to-many relationship. Then we have composite attributes, multi-valued attributes, cyclic relationships, and tertiary relationship. In the video that I sent, I clearly gave a demonstration, which I am not going to do unless there is someone who did not understand. Otherwise, when we are dealing with a many-to-many relationship, what essentially happens is you have those of you who watched the video. I made sure that I split the video into two. It has, the other one is 27, and also the part 2 is 27, such that you can be able to download it, and also it can be you can be able to have them saved on your phone without having a huge video. So those ones, I just removed them from class. Okay, so a many-to-many relationship, we're saying that if you have a many-to-many relationship, if you go back, for example, I am not going to do a full illustration because we already have this. So I'm not doing a full illustration. But for example, if we go back to this diagram here, between course unit and student, there is a many-to-many relationship, okay? Why do we say many-to-many relationship? We said that you look at the cardinality of the multiplicities of those two entities. That is when you can be in position to know the kind of binary relationship that those two entities are participating in. So in this case, the kind of binary relationship that exists between the course unit and the student is a many-to-many relationship. Now, in the video that I uploaded, I said that once you have this many-to-many relationship, what you do is you introduce an associative entity. You have to break what is allowable or what is permissible in, in relational database management system is one-to-many or one-to-one relationships. We don't have many-to-many relationships in relational database management systems. Many-to-many relationships can only be found in hierarchical database models or networked database models. But if you're dealing with a relational database management system, at the point of implementation, you have to make sure that you do not have any many-to-many relationship. And at the conceptual level, it's permissible for you to have it at the conceptual level. But at the logical level, you have to deal with all these unacceptable aspects of the ER model. So one of which is a many-to-many relationship. Now, between student and course unit, there's this many-to-many relationship. What do? You introduce an associative entity. This associative entity, which is also a weak entity, what does it do? It breaks down the many-to-many relationship such that you have what you call a one-to-many relationship on both sides of the entities. So if you put it here, like I said, I am not going to draw this thing again because I put these things in the video. So for purposes of not wasting so much time, okay? Hold on. So, assuming this is your, let me just put it aside here. Oh no.
Madam, we're not seeing your visual screen.
Oh, really? You have to keep reminding me because you see, you see it now?
Yes, we are.
Okay. I was trying to shift this. Okay. So like I was saying, that between course units and student, we have a many-to-many relationship. So we have to remove this many-to-many relationship, but by creating an associative entity. So in this case, between student and course unit, the associative entity, we are going to call it enrolls. Okay, so you have the student entity, the entity is going to be enrolled, and then you have student number, which is going to be a primary key, and then also you will have also have course code, which is going to be a primary key. So the associative entity has what we call a composite primary key. If you still remember, I said a composite primary key is a scenario where an entity has more than one attribute that is representing it as a primary key. So this is what we call a composite primary key. So the student number will be here and the course code will be here. This new relation is called enrolls. So what you have here is, that is a foreign key because it has to reference the primary table, and then also this is a foreign key. So on top of being a primary key, it is also a foreign key. So what happens is, I'm not going to remove this because I have to use this diagram for in our next class. So what happens, but you will see these things in the video that I posted. So what happens is you connect this to that, and you also connect this to that. So this original relationship has got to go out. It has to go away. This original relationship goes away. Okay. Let me just put it back. That original relationship goes away. So the student and the course unit will go through the enrolls associative entity, that is the new entity. And then this, you deduce this to, now this one, now you get a multiplicity, you put a 1-to-1 here and also a 1-to-1 here. This becomes a 1-to-many, and also this one becomes a 1-to-many. So this is how you deal with an associative entity. This is how you deal with a many-to-many relationship, okay? Justin, your hand is up.
Yes, madam.
Yes.
You've introduced an associative entity there, but I still see that composite entity called phone number.
No. This
And
is just, this is not supposed to be there. I'm just giving I'm just giving an example. It's supposed to be like that.
Okay.
This is
Okay,
that is a this is supposed to be like that. However, if there was a primary, if there was an attribute on the relationship type enrolls, remember this, the original relationship type was enrolled. The original relationship type was enrolled. If there was a relation, if there was an attribute on that relationship type, then all the attributes will have gone in that associative, in this associative entity enrolls, if at all it was there. But in this case, it wasn't there. So I need to go back and I remove these things. Okay. So that is how we deal with an associative entity. You will find it in the video. You even the chapters have already been uploaded. So please make sure that you also go and download the chapters, and then you try to understand these concepts.
The chapters are on Mwele.
Yes, the chapters are on Mwele.
Okay, thank you.
All right. So then a composite attribute, you only record the components of the composite attribute, because what you want is single, you need atomicity of your attributes. So you only record the components of the composite attribute. And then for a multi-valued attribute, you create a new relation for the multi-valued attribute, and you post the primary key of that multi-valued attribute. Let me show it. Let me try to just. So you have a multi-valued attribute called phone number. Okay. So what? So let's assume. So now we are saying for the multi-valued attribute, you create a new attribute, sorry, a new relation for the multi-valued attribute. So in this case, it is a phone contact. Okay.
Madam, your screen.
Oh. Sorry. So you create an entity for the multi-valued attribute. So this attribute, you remove it from the original table, And then this becomes your phone number, which is going to be a primary key. Phone number, which becomes your primary key. And then within that same table, you're going to put, because remember, this thing has staff number, staff member has a primary key, which is ID number. It was supposed to be one. I wonder why there are two there. I think maybe I did not delete it. So that is why it is there. So anyway, you get the primary key of this, and then you put it here, and then say ID number. So this ID number is going to act as a foreign key because it's the one that is referencing the primary table. Then you connect this to that. Remember, they said that a student has a maximum of 2 phone numbers. So you get a multiplicity, which is 2 to many, and then you put it on the side of the phone. Okay, you put 2 to many here. 2 to many, and then also this phone contact belongs to a given student. So you bring that multiplicity and then you put it here. So this is how you deal with multi-valued attribute. And then you say a staff member has phone contact, so that you remove the multi-valued attribute from the relation where it is, create a new relation for it, and then take the primary key of the relation where the multi-valued attribute was, and then post it in the new relation of the multi-valued attribute such that it acts as a foreign key in that new relation. Joshua.
Yes, madam, sorry to take you back a bit, but on this entity of student number, we've been talking about composite attributes. And then we said that address is a composite attribute, but for this particular, okay, does it become a composite when the question has specified, or attribute whenever we come across it?
Sorry?
All right, like for this attribute here, student number. Can you hear me?
In which entity?
A student number. I mean, sorry, for the student entity, sorry. This student entity here. So here we have student number, student name, and then address. So this address here is what I'm asking about, because we've said composite attributes. Like for example, address may have email or physical address or postal address.
Yes.
So I'm asking, is address a composite attribute only when it is specified in the question, or even when it's not specified, we take it as a composite attribute?
Just like what you have said, only when it is specified that it has components. So if they have specified that it has components, then it qualifies to be a what? It qualifies to be a composite attribute. Otherwise, if it is just mentioned the way it was mentioned, the same thing with telephone number, we were not told whether someone is going to have one to many. So the assumption here with telephone number is everyone has to only submit one telephone number. That is why in this particular entity called student, this telephone number is not a multi-valued attribute, because if they would say multi-valued, here, if you look at staff number, this is now a multi-valued. It has many values, implying you can submit more than one phone number, an Airtel line, an MTN line, an AfriCell. So it becomes a multi-valued because they have specified that you're going to have more than, the system is going to register more than one phone number for that particular individual. But for student, they said telephone number, implying you can only submit one phone number. So there is only one instance for that particular entity instance. Do you get it?
Yes, madam. Thank you.
You're welcome. So that's how we deal with multi-valued attributes. And then when we go to cyclic relationships, a cyclic relationship, remember we said that it is that relationship type that has only one particular, participating in only one entity instance. So where you have a cyclic relationship, you eliminate them by creating an entity along the relationship. In other words, where there is a relationship type, you create an entity for that particular cyclic relationship. And then tertiary, remember tertiary is n number of what? N number of entities participating in a given relationship type. In other words, you can have 10 entities or 100 entities, whatever it is. That is the tertiary relationship. You have n number of entities participating in a relationship type. What you need to do is, again, deduce all those entities such that you have a one-to-many binary relationship. But the most important thing here is, for example, if you have a relationship type where you have a ternary relationship, in this case, you have one relationship type and then 3 entity types. Those 3 entities, you create the 3 entities, but you need to create another entity, which is an associative entity that is going to link the 3 entities. And then that associative entity, by default, it takes all the primary keys of the other entities, just like how I described it in the video. But we shall see it more when we are describing, when I am teaching mapping. So when it is a ternary relationship, you introduce an associative entity such that you have 4 relations. When you have a quaternary, remember, originally, a quaternary has 4 entities and 1 relationship type. So what happens? You introduce an associative entity to make them 5 relations, such that the associative entity takes on the primary keys of all. I will demonstrate that further or much deeper in the next chapter for you to be able to appreciate. So that is how we deal with those aspects. So you can, the moment you are moving closer to physical design or physical implementation of the database, you have to ensure that all those things have been dealt with. So specialization and generalization. Issues of specialization and generalizations are usually associated with superclasses and a subclass, okay? So you have, sometimes a superclass is referred to as a supertype, or a subclass is referred to as a subtype. So an entity supertype contains the shared properties of all the subtypes. So in essence, what we are saying here is when you have a superclass, okay, it shares all its properties with the subclasses. And in the properties, we mean the attributes plus the relationships. So what do I mean by a superclass and a subclass? Again, I'll just give a very short. So let me share. Let me not forget to share. Here we are. So let's assume, let me first go and look. So we have this entity, Control-C, Control-V, and so we have an entity called employee. This entity called employee, we could have, let's say, a dean of a faculty. Then also we could have a lecturer. Okay, and then also we could have, let's say, a dean lecturer. And then also we have, let's say, a secretary or admin assistant. Secretary. Now, this employee has an employee ID, which is a primary key. The employee has a name, and the employee has a date of birth. Now, we represent, if I go back to, oh, sorry. We create this triangle is called an EER. It is the one that represents inheritance. And I am only doing this because I posted the video late. Otherwise, if I hadn't posted the video late, I wouldn't have done this again. But I posted it late. So that is why I am redoing this. Otherwise, I wouldn't have. So this does not have. Remember that subclasses don't have primary keys. Why? Because they inherit the attributes of its superclass. Now, this one here is a superclass. Employee is a superclass. And these ones here, these are subclasses. So this is sometimes referred to as a supertype. And these ones below here are sometimes called a subtype. So you can call it a superclass or a supertype, a subclass or a subtype. So this symbol, which is a triangle, is the one that represents inheritance, implying that all these subclasses inherit everything that the employee has or participating in. So in other words, a dean has an employee ID, an employee name, and a date of birth. A lecturer has an employee ID. So in other words, all these attributes are being inherited by all these subclasses. A secretary has an employee ID, an employee name, and a date of birth. However, what is key to note here is some of the superclasses may have unique features that other subclasses do not have. For example, a dean may have a dean ID. Okay, then you remove this. A lecturer may have another distinct feature, let's say qualification. And the secretary might have another distinct feature called typing speed. Okay, so those distinct features, okay, you just, what's happening? So those distinct features, you put them in the subclasses. Why don't we put them up here? Because the moment you put dean ID up here in the superclass, it means that also lecturer, dean ID applies to a lecturer, dean ID also applies to the secretary. The same thing applies to qualification. The moment you put up here, when there is this symbol of inheritance, it means that the lecturer, the secretary takes on qualification and the dean takes on qualification. So the aspect of specialization implies that all the attributes are inherited by the superclasses and the relationship type that this superclass is participating in. So for example, if there is another, because we said there is attribute inheritance and relationship inheritance. So there's also, let's say an employee belongs to a department. So we have a department ID. Then we have a department name. And let's just leave it there. And then, so we say that so an employee belongs to a department. Okay, so when we take this side and then we post it here, and then our relationship type, oh, sorry. The relationship type is belongs. And then this employee could also be, this employee could be, here we say payment. Let's say, what can I say? Let's create an employee. That's what other relationship belongs to the department. An employee receives payment. Okay, let me just say, or salary. Yes, let me just say salary. And then here we say we have the salary ID. And then we can say here bank number, whatever it is. And then also we create this relationship here. And then we say, drawing these things is not easy. Interesting. An employee receives a salary. An employee receives a salary. Oh, sorry. No, we said that with inheritance, the subclasses inherit all the attributes of each superclass plus all the relationship types that this particular superclass is participating in. So in essence, that the dean, lecturer, and secretary inherits the relationship type belongs, and then also they inherit the relationship type receives. So in essence, we're saying that the dean belongs to a department, the lecturer belongs to a department, and the secretary belongs to a department. The dean receives a salary, the lecturer receives a salary, and the secretary receives a salary. So that is what we refer to as attribute inheritance. That's what I wanted to demonstrate. So that is a superclass and that is a subclass. So what you need to know is the relationship between a superclass and a subclass is always a one-to-one relationship. It does not change. It's always a one-to-one. But the kind of participation between a superclass and a subclass can be mandatory or optional. That kind of participation. It can be mandatory. It can be an optional participation. So what I have just explained, drawn, where I said certain attributes may apply to some, but not all of the entities. Like I said, under the dean, under the lecturer, dean, there is a dean ID, lecturer had qualification, and secretary had a typing speed. So those particular attributes do not belong to any of those subclasses. That is why we specifically put them in the subclass where they are supposed to be. Otherwise, if you put them in the superclass, it would mean that they apply to all the subclasses, which may not be the case. Okay, so that's what I've explained. So the properties of a superclass and the subclass, the member entity of the subclass represents a real world entity. So in essence, when you are implementing a superclass and a subclass, what you need to know that a subclass exists in the database as an entity on its own. Okay, it is a real object that is represented in the database. So the subclass member is the same as an entity of the superclass, only that they may have distinct only that the subclasses may have distinct roles, like what we have seen. So when implementing a subclass or a superclass relationship, the member of the subclass may be represented as a distinct database object that is the same. So an entity cannot, the properties of a superclass and a subclass is such that an entity can never exist in the database just by being a subclass. It can never exist. It always has to be a member of the superclass. That is when it can exist in the database. And we are saying that an entity can be a member of more than one subclass. What am I saying? That where you have, like, for example, where you have the employee, where you have this employee entity, we're saying that this employee entity can participate in more than one subclass. What does that mean? It means that this employee can either be a dean and a lecturer. Example, in Makerere University, that is exactly what happens, because in most cases you are first a lecturer, and then throughout your being at the university, then you are elected as a dean. So what it essentially means that a superclass can participate in more than one of the subclasses. So this is the kind of relationship that, for example, we have at Makerere University. Remember, we said that these things is the relationship that exists between the employee and the superclass and the subclass is a one-to-one, but we don't represent that in the ER model. However, you can represent the participation, okay? Like whether we shall see what all these things mean towards the end of this class. But mandatory, it means that when you're talking, there's what we call constraints. So we have a constraint which we call a disjoint constraint, which is represented as either, and it can be an or an and then we have participation, which is mandatory or optional. So with this mandatory, if you have a mandatory here, it means that this particular employee or this particular superclass must participate in at least subclasses. So when you have mandatory or, it must participate in at least one of it. Sorry, it can participate in not more than one subclass. That is why we have an or. So this superclass can be a dean, can be a lecturer, can be a secretary, but cannot be any two. That's why we have an or, but it should be. But if you have a mandatory and, okay, where you have a mandatory and, it means that this particular superclass can participate, okay, in more than one subclasses, where you're saying an employee can be a dean and a lecturer, an employee can be a lecturer and a secretary. That is the mandatory and. Also, you can do it with optional and so on and so forth. Anyway, what I wanted to show you here is to tell you that a superclass can participate in more than one subclasses, and you can for example, you can have more than one specialization for this particular employee. You can have this specialization by job role, but you can also have a specialization up here, another one, let's say by the type of payment or the terms. So where you have someone who gets a monthly salary, and where someone gets a wage. So in this case, it means that this particular superclass can participate in also another specialization. So in this case, if you are to draw this onto this, and then you bring this up here, So that is also possible and very, very applicable. So you can say an employee who is a dean, okay? An employee can be a dean and a monthly salary kind of employee, or an employee can be a lecturer who is earning a wage. So they can also participate in more than one specialization. I just needed to show you that such that when we go back, I don't have to come back this side. So an entity can be a member of more than one subclass. That one I have explained. It is not necessary that every entity in a superclass is a member of the subclass. So what we are saying here that a superclass does not necessarily mean that a superclass can participate in a subclass. What does that mean? It means that you can be just an employee, but when you're not a dean, when you're not a lecturer, and you're not a technician, sorry, a secretary. So this is the statement. It is not necessary that every entity in the superclass may be a member of a subclass. You can just be an employee who is not taking on any of the subclasses. So the type of an entity is defined by the attributes and the relationship type. So what happens in superclasses, it inherits the relationships and the attributes that I have explained. So a specialization is a top-down design process, okay? Like how I was explaining the top-down design approach. So this is one way. So you have a top-down design process where you start off with the high-level entities, and then you incrementally add the low-level entities. So here you have, I said that EER is the one that represents inheritance. The same entity type may have several specializations. That is what I have said, that you have an employee who is a salaried employee or who is a waged employee. At the same time, you have an employee who is either a dean, a lecturer, or a secretary. So a particular entity can have several specializations. That is what it means. So now we have generalization. It's a reverse of the specialization. This is a bottom-up approach that starts off with the low-level entities, and then it goes up into the high-level entities. So when you're talking about specialization and generalization, these terms are usually used interchangeably. So at the end of the day, when you have a diagram, an ER diagram, no one can know that this was a specialization diagram or this was a diagram as a result of generalization, because these things are used interchangeably, okay? So imagine you have these two entities. After finishing, when you draw the diagram, for example, this diagram, and you have it here, would you know that it was a result of a generalization or specialization? No, you will not be in position to know that. So for example, here you see that car and truck is a specialization, a generalization of vehicle, and vehicle is a specialization of car and truck. So it's not something that really should bother you in getting to know or in trying to get the difference. The only difference between the two is one is top down and the other is bottom up. But the rest, the concepts are the same. So we have different constraints of specialization and generalization. One, we have what you call a disjoint constraint, which is either an or an and we have participation, which can be total participation or partial participation. So you have these two types of constraints that we have to use when we are dealing with specialization and generalization. So the disjointness constraint has what we call a disjointness. Okay, the or, I usually want to call it the or. We have the or constraint. So what does the or constraint mean? The or constraint specifies that the subclasses of a specialization must be disjoint. What exactly do we mean? We mean that an entity can only participate in one subclass for an or. So in this case, a client can only be an individual client or company client, but cannot be both. So even if you had 10 subclasses down here, when you have an or constraint, it means that it can only participate in one of the subclasses. That is the disjoint constraint. And then the overlap constraint, and it means that this superclass can participate in more than one of the subclasses, where you're saying a student is doing a course, but they are doing DIM, and they are doing SAD, and they are doing internet programming. So that means that for that particular superclass, it can participate in more than one of the subclasses for that particular specialization. That is the overlap constraint. And then you have, when you go to the complete or participation constraint, you have total participation, which is sometimes referred to mandatory. And in the mandatory participation, it means that this superclass has to participate in one of the subclass, must participate in one of the subclasses. This is the mandatory, okay? And yet the optional means that it may or may not participate in any of the subclasses. So in this case, you can have an employee, okay? Let me first push this out. You can have an employee. It's optional for this particular superclass to be a manager and a secretary. So in other words, you can just be an employee when you're not a manager or when you're not a secretary. That is the optional participation. So these are the 4 constraints, and this is how we write them. You always have to start with the participation, and then you end with the disjointness constraint. And those are specifically the 4 types of constraints. You cannot have any. So it's either a mandatory or a mandatory and, an optional or an optional and. For specialization. So these are just diagrammatic illustrations that represent these different kinds of concepts. For example, a staff member, it's optional for a staff member to be any of this, but if he has participated in any of this staff member can be a manager and a secretary. It can be a manager and a salesperson. This is the optional and. So the optional is this, that a staff may participate in any of this. And should they participate, then they can be either a manager and a secretary, a manager and a salesperson. That is how it is interpreted. Then we have also this example here, where you have another thing that you need to take note of is a subclass can be a superclass of another subclass, okay? So in this case, you can have a secretary and then also have an assistant secretary. But the kind of participation that exists between these 2 subclasses, this is a subclass, which is a superclass of a subclass, is always an optional participation. Always, it is an optional participation. So we have a sales manager who you have a manager and a salesperson who is participating in a sales manager subclass. Then you also have a secretary, which is a subclass participating in another subclass. So